Hi friends, and this is Venkat. And now let me show you how my robot works. My robot is actually controlled by an accelerometer. It's accelerometer controlled system. It has an accelerometer, an Arduino mainboard, an Arduino mainboard. This is the Arduino mainboard, and these are the switches for controlling the system. And this is a self-made obstacle detector, and this is an alarm to indicate an obstacle, and this is the driver. And I have used two motors, two 12-volt bidirectional DC motors. Now the accelerometer on still position, so that it won't be moving. And now when you tilt the accelerometer towards the forward direction, both the motors will be rotating on the clockwise direction, thus enabling the robot to move forwards. Now I have made it again to still position, and now when I move it towards the left, this part of the motor will be rotating in the anti-clockwise direction, and the other will be rotating on the clockwise direction. Again on still. Now when I move it backwards, both the motors will be rotating on the anti-clockwise direction. Still. Now when again I make it towards the right, the motor it will tend to rotate right by the anti-clockwise motion of this motor and the anti-clockwise motion of this motor and the clockwise motion of this motor. It will tend to rotate towards the right. Now still. These are the four controls. I also made it in such a way that when you move it towards tilt it forward, further the speed will increase. This has been achieved by pulse width modulation. Backward motion. Towards the left and towards the right. Now let me transfer the system onto switches mode. I'll be doing it by disconnecting this wire. I've disconnected this wire, and the control will be automatically transferred to this spot. Now there are switches, and these are used for 4 direction switches. And when 2 of these are excited, or when 2 of the switches are turned on, the system will be transferred to intelligent mode. Now let me show you. And this is the forward switch. Both the wheels will be rotating. Both the wheels will be rotating in the clockwise direction, clockwise change. When I off it, the system will on. When I move this, the system will be rotating towards the right. This can be achieved by the see the system rotating. The reverse motion of this side and the forward motion of this side will make the robot turn towards the right. Now let me switch it off. When I enable this part will be rotating towards the right, forward, clockwise. This will be anti-clockwise. So this will make the robot to turn towards the right, and this will make the boat to move towards the backward direction. This is enabled by both the wheels will be rotating in the backward direction. Both the wheels will be rotating on the backward direction. Then again it will stop. When these 2 switches are turned on, the system will be driven onto intelligent mode. It will tend to move towards the forward. When an obstacle is encountered, an alarm will be sounded. See, an obstacle comes, will be an alarm. And also, in addition to that, it will have an automated turning system, so that it will evade the obstacle. For example, I consider an obstacle is coming here. Motor is rotating in the clockwise direction. When the obstacle is encountered, it will automatically turn to anti-clockwise. There is no obstacle, the motor is rotating clockwise, and there is an obstacle, obstacle clockwise, obstacle anti-clockwise. Here also, when there is no obstacle, the system is rotating in clockwise direction. Obstacle, the direction changes. So that programmed it in such a way that when the motor goes and it counts an obstacle, it will tend to rotate, so that it can evade the obstacle. When these two wheels will be rotating in the clockwise direction, so that it will tend to move forward. When an obstacle is encountered, this wheel will tend to rotate in the anti-clockwise direction, so that it will provide a tilt to the robot, and it will tend to rotate right. Thereby, it can evade the obstacle in front. This is the self-made obstacle protection system. And when an obstacle comes, the luminance intensity I have made it in such a way that these are LEDs, and inside this is an LDR. LDR is positioned right at the middle of the system. When usually the luminous intensity will be low in this part, in the inside of this cylinder. When an obstacle comes, the luminous intensity increases in this part. When an obstacle comes, the luminous intensity will be increasing in this part, and this will be also be transferred to the cylinder, and thereby can affect the resistance of the LDR. I have programmed it in such a way that analog input will be given to the board through the pin A1. This pin. So I also programmed the system in such a way that when an obstacle comes, the resistance is lowered, as alarm will be sounded. See.